This is my new sequencer design. There is a pretty cool feature. It's pretty similar to the clay sequencer, but I made some cool modifications to make it suit myself. So basically, there is a 4017 Johnston counter, and it's set up with 8 steps, 0 through 7 here, and it is feeding 8 outputs to these 8 dip switches here. And basically, through manipulating these dip switches, we'll put a certain clock signal in to the first data input on this octal flip-flop. It's a 7HC374 flip-flop. And then I have it set up as a serial to parallel shift register with 8 stages, so meaning the Q output of each flip-flop is fed into the D output of the next successive flip-flop, and then each of those outputs are on each of these LEDs. Excuse the very messy breadboard wiring. And so the way you can load a sequence to this is that you manipulate each one of these dip switches. So if I put the first one up, you shift 1 bit through. And this is meant to be a 16-step sequencer, so this is just half of what it would be. And then I can change the speed based on changing the clock. And you can load in a new sequence on the fly, which is nice, rather than the CLE where you have to hit a load button. But that can be advantageous in some situations if you want to wait until a measure finishes and then load up the new sequence. But I can change the sequence by adding more bits in different spots on the dip switches and making a cool, interesting sequence. And this LED is just the clock. Get rid of that. You can see you can get some pretty interesting sequences. And these would obviously be going to potentiometers to make a control voltage. And then, yeah, that's pretty much all I got so far. And it is very hypnotizing. I mean, this may not be one of the most efficient ways to do it, but with the parts I had on hand, this is a pretty nice design.